I'd like to talk about another physical property called density. And this is one that relates mass of a substance to its volume. And it is going to have units that actually incorporate both mass and volume units. So density is usually reported in terms of, grams per milliliter. And this makes sense if you look at the density formula. So you can calculate density by dividing the mass of something by its volume. And so our units are like grams per milliliter, which is grams divided by milliliter. So similar to something like miles per hour, which would be miles divided by hours, which is how we talk about our speed when we're driving, right? And so this is a little bit different because it's not about, our motion. It's instead about how heavy something of a size is. So this is a physical property that's going to be unique to each different type of substance. And it explains how some things float and some things sink in another substance. And we'll use this in this class because sometimes we'll have those heterogeneous mixtures and we'll use density to determine which one is going to be lower than the other if we have two liquids layered on top of each other. And then we could take advantage of this to extract things and wash things. And it's a readily used technique in organic chemistry. So in this picture right here where we've got, it's like a tub with water and it has something floating and something sinking. So here's our water, H2O. Here's a penny. And so this penny has sunk to the bottom of the water. And this means that the density of the penny is larger than the density of the water. Now this object up here is floating on the top of the water on the surface. And so I don't even know what it is. The density of this block, that's the shape it is at least, is going to be much less than the density of the water. And so it's going to float on the top. So it'd be on the top of it. So it's going to have less mass for a volume than the water would. Similarly, then we can say that this block has less density than the penny does when we compare just those two rather than comparing them to water. And so things that have a low density are going to, if you're holding two objects that are the same size, the one with less density will be the one that feels a lot lighter. And the one with that larger density will feel much heavier. And we can use this. So one way that this is used is in ice water hash making. And so if you take plant material that's coated in trichromes all around it, those are going to be oils, and those are going to be heavier than the plant material itself in the water. And so what happens in the ice water is that the plant material is less dense, and so it's going to float on the top, and the oils and the hash part is going to fall to the bottom because it's more dense. And so by agitating, and you can separate them, and then you can use their densities in water to actually physically separate them. And then it's easy to kind of like take off the plant material and pour the water and then isolate the hash at the bottom, the ice water hash. And so we can use density like in these physical separations. And we can also take advantage of density when we do extractions. And we'll talk about that further down in the quarter. In general, though, you'll see densities typically reported. So a good one, I think, actually to have in mind is the density of water, because we compare to it a lot. If you've ever brewed beer, you know that you usually measure specific gravity before and after you you ferment, and that allows you to calculate the amount of alcohol that has been generated. And that specific gravity, when we're doing that, we're really looking at the density of the liquid compared to the density of water. So the density of water at room temperature is about 1.0 gram per milliliter. I know it's really convenient, right? And so things that would float on water would have a density of less than 1. And so I would expect this density block to maybe it's 0.3 grams per milliliter. And the penny that would have to be larger than 1.0. So we can maybe expect it to be something like, I don't know, 3.0 grams per milliliter, something like that. And if you wanted to calculate the density and do a measurement, you could, so if you wanted to calculate it, you would need to know the mass of the object and the volume. And so maybe you weigh this out, and it's 2.0 grams, right? And then the volume, you measure that, and I'm going to draw a graduated cylinder, and you'll see what these look like in the lab. And you maybe displace water, you figure out that the object that you're trying to calculate the density of has a volume of, let's do 0.5 milliliters. So my density would be equal to 2.0 divided by 0.5 milliliters, because I'm going to use my mass, which was that 2.0 grams, and divide that by my volume, which is that 0.5 milliliters, to calculate what my overall density is. And so that is going to be, it'll be about 4 grams per milliliter. And I'm just going to plug that into a calculator or do it in my head, kind of depending on who I am. Yeah, so that's density, and we'll talk about that more throughout the quarter.